Good morning, third grade. Our targets for today are I can identify area story problems and I can represent area division story problems using pictures and graphs. Let's review what we already know about division. We know that multiplication is putting equal-sized groups together to find an unknown product or total. Division is the opposite. It's breaking apart a known total into equal-sized groups or rows to find the unknown factor or piece of information, the unknown side length. We also know that inverse operations are operations that undo each other. Addition and subtraction are inverse operations. They undo each other. For example, 7 plus 3 equals 10. 10 minus 3 equals 7. Multiplication and division are also inverse operations. For example, we know 6 times 5 equals 30. 30 divided by 5 equals 6. We know when we're talking about multiplication that the product is the total amount. It's the answer to a multiplication problem. We know that a factor is one of the numbers we multiply. In the equation 4 times 5 equals 20, 4 and 5 are both factors. 20 is the product or total. In a division equation, your total amount is called the dividend, and it is the first number or the number we're dividing in a division problem. The divisor is the amount you're dividing by, and it is the known factor. The quotient is the answer to a division problem, and it is the unknown factor. So in the problem, 20 divided by 5 equals 4. 20 is the dividend, 5 is the divisor, and 4 is the quotient. We can rewrite any division equation as a multiplication equation. We know that the dividend is the total, which then becomes the product. The divisor and the quotient are then both factors. So for example, I could take the problem 15 divided by 3 equals 5 and turn it into the multiplication equation 5 times 3 equals 15. This is very helpful for us because it's easy for us to think about multiplication equations, and in fact we know most of our multiplication facts, but division equations are much more difficult for us to think about. So we can always use a multiplication equation to help us think about a division equation. We also know that area is the amount of space covered by an object. It's the total number of square units. And a square unit is what we use to measure area. It's a measurement whose sides have exactly the same length. To find the area of a rectangular object, we multiply the length of the rectangle times the width of the rectangle. For example, this rectangle is 5 units long and 2 units wide. So to find the total area or the total number of square units, I would multiply 5 times 2. 5 times 2 equals 10. So I know that the area or the total number of square units in this rectangle is 10. Area is always measured in square units. So the answer to an area problem always includes square units. The area of this rectangle is 10 square units. Sometimes we end up knowing the total area of a rectangular object as well as either the length or the width of an object. You can see here I know the area of this rectangle is 10 square units and I know that it's 2 units wide. I do not know in this case how long the rectangle is. When this happens, we're trying to find either the length or the width of the object. In this example, we're trying to find the length because the length is unknown. To find an unknown length or width of a rectangle, we divide. We would take the dividend, the product, the area, and we would divide it by the known piece of information. In this case, we would divide it actually by the width, even though this says length, because we know the width is 2. And that would tell us the missing information. If our divisor is the width or how wide it is, then the quotient is our length, how long it is. Alternately, if we do not know the width, we divide area divided by length to find the width. In this particular example, we can divide our area, our total amount, 10, into 2 groups because we know the factor 2. We would divide 10 by 2. You can see I've done that here. And n will be how many items are in that group or how long it is. I can see that in this case, I could also think about this as 10 equals 2 times n. So I would think to myself, okay, 2 times what equals n? Well, I know 2 times 5 equals n. So I know that 10 divided by 2 equals 5. Today we're going to be solving area division story problems. Area problems are problems that represent the amount of space covering square units in a rectangular shape. Area division problems involve areas where we know the total amount and one factor, and we're looking for the other factor. An example would be, the wall was 5 feet high and covered 40 square feet. How long was the wall? Since I know the width of the wall and also the total area, I would divide the total area divided by the width, or how high it is, to find the length. 40 divided by 5 equals 8. So the length of that wall would be 8 feet. Let's go ahead and look at a couple of area problems. Some of these are area multiplication, and some of them are area division. Area multiplication and area division are very, very similar, just like how equal-sized group multiplication and equal-sized group division are very, very similar. The only difference between an area multiplication problem and an area division problem is that in an area division problem, you know the total area. But in an area multiplication problem, you're trying to find the total. You do not know the total. So let's take a look at these problems and decide if they're area multiplication or area division. The court at Logan's house is 100 square feet. If it's 10 feet long, how wide is it? Well, I notice right away that I know the total area, 100 square feet, and I'm trying to find how wide it is. Since I know the total, I know that this is an area division problem. Here's our next problem. Genesia's treasure chest lid is 6 feet wide and 4 feet long. What is the total area of her treasure chest lid? I notice that in this problem, the question is asking me to find the total area. So, since I do not know the total area, and I do know the length and width, I would multiply to solve this problem. You're going to determine the last 4 independently. The Roberts' new pool is 8 feet wide and 9 feet long. What is the total area of this pool? I notice that we do not know the total area. That's what we're trying to find. So is this area multiplication or area division? You're right. Because we do not know the total, this is an area multiplication problem. What about this next problem? Mrs. Moore's desk is 4 feet wide and 8 feet long. What is the area of her desk? Is this an area multiplication or an area division problem? You're right. This is an area multiplication problem because we do not know the total area. We're trying to find that. Look at the next problem. Josiah's book is 16 square inches. If it is 4 feet wide, how long is it? I respectfully agree. This is a division problem because we know the total area, 16 square inches, and we're trying to find the length. Here's the last problem. Ethan's bedroom is 45 feet. Ooh, I'm noticing a mistake. 45 square feet. If it is 9 feet, here's the last problem. Ethan's room is 45 square feet. If it is 9 feet long, how wide is it? I respectfully agree. Since we know the total area and we're trying to find the width, this is also an area division problem. Third grade area division and area multiplications are very similar, so you really already know a lot about them. You know that there's still a rectangular item with a length and a width, and a total area, or how much space is covered. Again, the only difference between area multiplication and area division problems is that in an area division problem, you actually already know the total area, and you're trying to find either the length or the width. You divide to solve that problem. So third grade, we're going to use our problem-solving process to solve area division problems, just like every other story problem we might solve. Step 1, we'll read and understand, figuring out what we know and what we're trying to find out. Then we'll plan, we'll determine the problem type and organize the information. Third, we'll solve by choosing an operation and actually solving the problem. And finally, we'll look back and check to see if our answer is reasonable. Here's the problem we're going to solve together today. Jessica's kitchen nook has 24 square feet of space for a table. If she wants the table to be 6 feet long, how wide can it be? We're going to start with step 1 by reading and understanding the problem. So third grade, let's look at this problem and think, what information do they give us? Jessica's kitchen nook has 24 square feet of space for a table. If she wants the table to be 6 feet long, how wide can it be? I agree. One piece of information they give us is that the nook is 24 square feet. Since it's saying square feet, I know that's the total area. I know the total, so this is an area division problem. The other piece of information they give us is that the table is going to be 6 feet wide. Of course, the piece of information they tell us is that the table is 6 feet long, and the question is asking how wide can it be. So we're going to go ahead and actually start with our grid this time. Let's put the information we know on the grid. Well, we're we're going to go ahead and plan and solve this problem. We're actually going to start third grade with the grid this time. The grid's going to be very helpful for solving this area division problem. Let's put the information we know on it. We know that there are 24 square feet, and since that's the total area, that's going to be the total area of the rectangle. The other piece of information I know, the factor I know, is that it's 6 feet long. I'm trying to figure out how wide the table is going to be, so n feet wide is my unknown information. Now, third grade, we're going to go ahead and figure out what size this rectangle would be. Well, if the table was 6 feet long but only 1 foot wide, it would be a 6 square foot table. We know the table is going to be 24 square feet, so 1 foot wide isn't wide enough. What if it were 2 feet wide? Well, 6 times 2 is 12, so if it were 2 feet wide, it would have an area of 12 square feet. That's not 24 square feet, so that's not wide enough. If it were 3 feet wide, 6 times 3 is 18, and again, 18 square feet still isn't 24 square feet, so 3 feet wide isn't wide enough. But if it were 4 feet wide, 4 times 6 is 24. So 4 feet wide is exactly the right width for this table. Now we can draw our picture. I'm going to draw a rectangle. One square on this problem represents, of course, 1 square foot, because all of the squares are all the square feet. Now, third grade, I'm going to go ahead and draw a rectangle that pretty much looks identical to the rectangle on the grid. I know that this item is Jessica's kitchen nook, and it's 24 square feet. Again, I'll put that it's 6 feet long and 6 feet wide. Now, third grade, we're going to ask ourselves, what are we trying to find out? The question asks, how wide can it be? So we're trying to figure out how wide the table can be. We're ready for step 3. We're going to choose an operation and solve. This is an area division problem because we know the total area and we're trying to find how wide it is. So we're going to write a division equation. What will the dividend be in this problem? I agree, 24 square feet is the total amount of square feet. It's our dividend. What are we going to divide that by? What is the factor? We know. What is our divisor? I agree, 6 feet long is our divisor. And of course, this is going to tell us n, how many feet wide the item is. What multiplication equation would help us solve this problem? I respectfully agree. 24 equals 6 times n is going to help us solve this problem. I want you to think to yourself, 6 times what equals 20 equals 24. What would n equal? I agree. N equals 4 because 6 times 4 is 24. So 24 divided by 6 equals n. I want you to think what would be an excellent third grade answer to the problem, to the question, how wide can this table be? I agree. An excellent third grade answer would be the table can be 4 feet wide. We're ready for the final step to look back and check. We're going to look at our answer to see if it's reasonable. But first, we're going to answer this last question. How do we know our answer is correct? Well, how do we know that 24 divided by 6 equals n? We know that 24 divided by 6 equals 4 because 6 times 4 equals 24. Let's quickly double check. Are 24 and 6 the numbers from the problem? They are. Is 4 the correct answer to 24 divided by 6? It is because, like we said, 6 times 4 equals 24. So 24 divided by 6 equals 4. Thank you for solving this area division problem with me today, third grade. We'll learn more about solving area division problems tomorrow. Have a great day.